Let's practice writing a proof together involving some triangles. For this proof, let's go ahead and write a 2-column proof, and let's look at the given information that we have. Alright, first up, we're told that segment MO is going to be perpendicular to segment NP. So here's segment MO, and here's segment NP. In addition to that, we're told that segment MN is congruent to segment MP. That means that this segment right over here is congruent to or is the same length as this segment over here. Let's go ahead and use that information to prove that triangle MON, which is this triangle right here, is congruent to triangle MOP, which is this triangle right over here. Now, hopefully we understand the situation a little better and what that given information means, and let's go ahead and see if we can prove that these two triangles are indeed congruent. Let's get started on our 2-column proof. Let's just go ahead and write the information that we were given, and we'll just go ahead and write given for the reason right away. But what about for statement 2? For statement 2, let's go off of this information that we're told about MO being perpendicular to NP. Because those two segments are perpendicular to each other, we can say that angle MON is a right angle, which is this angle right over here, and that angle MOP is also a right angle, which is this angle right over here. We can go ahead and say this by the definition of perpendicular lines. So we knew that MO is perpendicular to NP, so we know that they create two of these right angles. Now that we confirm that each of these triangles has a right angle, we can say that triangle MON is a right triangle, and that triangle MOP is a right triangle. Hopefully this makes sense because both of these triangles have a right angle, which fits the definition of right triangles. So we use that given information that these two segments are perpendicular to each other, and we were able to establish that we have two right angles. We have a right angle at MON and another right angle at MOP. So we established that both of these triangles are going to be right triangles. And so now that we know that both of these triangles are right triangles, we could potentially prove that these two triangles are congruent by the hypotenuse-leg theorem. Keep in mind that we already know that segment MN and MP are congruent to each other, and those are both the hypotenuse of each of their respective triangles. And so if we can prove that one of the legs of these two triangles are congruent to each other, then we can go ahead and use that HL theorem and prove that the triangles are indeed congruent by that theorem. Alright, for statement 4, I'm not going to use any of the given information. I'm just going to be looking at the picture and seeing if we can find out another piece of information. Notice how these two triangles share this segment of MO, which is going to be the same leg for both of these triangles. Since MO is shared by both of these triangles and it's the same exact length. Now this seems a little silly, but to be clear, this MO over here could be representing this MO segment that is a part of the triangle to the left, or triangle MON. And then this other MO that we have here is itself, but this is also going to be a leg of this triangle to the right, or this leg of triangle MOP. And the reason we can say this is the reflexive property of equality. Now remember, MO is a congruent leg of both of these triangles, so we know that we have a leg that is congruent on both of these right triangles. So we established that we had right triangles. We also established that they have the same hypotenuse, or their hypotenuse are congruent, but also that they have corresponding legs that are also congruent. So from this, we can conclude that triangle MON is congruent to triangle MOP by the hypotenuse-leg theorem. And so in the future, if you're dealing with another proof and you can see that you have right triangles, you might want to consider seeing if you can find out that the hypotenuse are indeed congruent as well as one of the legs, and you could go ahead and use that HL theorem to prove the triangles are congruent. If you found the video helpful, please consider giving it a thumbs up and letting me know in the comment section down below. And as always, keep up the great work that you're already doing, and I'll see you in the next one.